Hello, my name is Maria Espinosa, and today we're going to look at proton and carbon-13 NMR spectroscopy for the molecular formula C6H10O. Proton NMR will help us to determine the number and type of hydrogen atoms in the molecule. Plus, it will help us to determine the structure of the carbon chain. First, we need to analyze the number of peaks on this image. This example will be based in C6H10O. We can see we have around 1, 2, 3, 4, and 5 peaks. The first peak has an integration of 2, the second one an integration of 1, and then the last 3 with an integration of 2, 1, and 3 respectively. And now by comparing the peaks and how they are arranged and analyzing their chemical shifts, we can see how this first peak that we see here falls into around 5.2, 5.3, generating the presence of a double bond between carbon and carbon. So we can circle this one. The second peak with an integration and falls into around 4.1, which shows either the presence of an alcohol bond between carbon and oxygen, which we have an oxygen in our compound according to the molecular formula. The last 3 peaks are between 1 and 3, and they can symbolize CH3 bonds, CH2 bonds, and that will give us an idea of how we can arrange these 6 carbons. According to this information, we can develop a ring based on 6 carbons, definitely with the presence of oxygen, so an alcohol. Using one of our hydrogens, we still have 9 left. And then we can add a double bond in the ring according to this information right here, giving us this hydrogens filling the number of hydrogens that we should have in our molecule, and we will end up with 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Now looking at coupling, we can see a triplet around here, a singlet around here, a doublet here. This can be considered a quartet, and then a singlet here. According to this information, we can arrange our carbons in a bond. Now looking at NMR, carbon-13 NMR for our molecular formula C6H10O, we can identify 6 different peaks, meaning that there are 6 different carbon environments for this molecule, so no symmetry for our compound. The first 2 peaks that we can see here symbolize the presence of a double bond between carbon and carbon. The following peak close to this double bond is between 50 and around 75, 70, symbolize the presence of an alcohol attached to a carbon. And then these last 3 peaks are the other carbon environments. So if we draw our molecule with a double bond here, an OH here. We can see how this carbon's environments are these two peaks right here. The other two carbon environments that we see are this one and this one. And then the last two other carbon environments are these two right here.